Back. I hope we're having a good day. So I say we're going to start on page 30 because page 30 has to do with the sample quest problems. And so we'll start with our calendar. Coming up this Monday is quest number 3. It is on classes 19 to 23, which is starting here and going down to here. So it's those topics. It's basically exponents. Exponents and radicals. That's the focus of this quest. Tenzin had asked if there are any word problems on the quest. The answer is no. There's no word problems. It is really just, can you simplify exponents? Can you simplify radicals? Okay. So in terms of preparing for the quest, well, you've got all the homework that you've been doing, and if you haven't done it all, then Monday is the last day to turn in, the recent homework assignments if you've missed any. But I said open to page 30 because that's where you will find what I consider a very valuable resource, and that's the practice problems for the quest. And so I've highlighted here the YouTube phrase that you type in. You will find videos of me going through all of those problems. I've been a little bit surprised at how few views these YouTube videos have gotten. So I'm hoping that more people, I'm hoping that it's a good resource. And if it's a good resource, I want you to take advantage of it. So hopefully, if you have some time, you're going to go through these practice problems. At bare minimum, this is what you should be doing to prepare for the quest. There's an answer key that's a few pages away, but you'll also find the videos on YouTube. Here are the answers in here. Okay? Yeah, Ben. What are they? Okay. You know what the videos are, right? Yeah, so it's me going through those sample quest problems. So you'll hear me and you'll see me writing stuff on the board. Step by step. Yeah. Okay, so that is that, and I think that's good. I can pull up another document real quick. So also another resource for you up on Moodle, you will find this PDF, which if you take a look at those sample quest problems, you'll see these are the first couple, right? 4/4 to the -2, I think, is the very first one. And so when I made the video, I did everything in color, so it's not just the answer. The answer to this problem is 64, but the process that I went through. So this PDF color document is on Moodle, so you can check that out. It's certainly more robust than the answer key, not as good as the YouTube videos, but it's something, okay? So that's up on Moodle. All right, so that is that. Next thing I want to say, so we can come back here and we'll actually begin. I think we might be on the right page here. Page 33 is where we start today. But before we do, I just want to mention that there's an important date coming up in terms of the GCC calendar. Oh, yeah. Oh, good question. The quest will start, what have we been doing in the past? 12:30 to 2:30, right? Yes, 12:30 to 2:30. So show up half an hour early on Monday if you want some extra time. Okay. Thank you, Michelle. Okay, so this coming Tuesday here at GCC is the last day to withdraw from a class and get a W. This coming Tuesday is the last day to withdraw from a class and get a W. So for people that are failing or are in danger of failing, it's an opportunity to really think, okay, what are the chances that I'm going to get through this course if I stay in? And if you feel like there's really no chance that you can pass the course, then maybe it's better to have a W than an F, and then you retake the course at a later date. So here's the deal. If I'm going to try to stare at the back wall so nobody thinks I'm talking to them. If you are in danger of not getting through this, it's so weird, but if you're in danger of not getting through this course, let me know today if there's any possibility that that you might withdraw from this course. Because if that's a possibility, then I want to grade your quest first on Monday. And I want you to stick around on Monday, and maybe we can have a chat like 10 minutes after class, and I'll have your test graded, and then we can really talk about your standing in the course. Does that make sense? Right. So if there's any chance that you might be considering withdrawing from the course, I want you to have that information. But you're not going to get it if you wait for me to give the quest back on Wednesday. Okay. So just let me know today, and we can figure out a plan for Monday if that's the case. Okay. So we are here on page 33. I'll remind you that last class we factored lots of trinomials. For example, we did stuff like this, x squared minus 7x plus 12. And then do you guys remember the little two-letter thing that we wrote down up above? PS, where does the P go? It's the last thing at the end, and the S is over here. So we wanted two numbers whose product was, I didn't circle the plus sign. Whose product is positive 12, and whose sum is negative 7, right? That's what we were after. We made a nice little table. We find the answers. We factored it. Unfortunately, things are much tougher when the a, which is the thing in front of the x squared, is not 1. So here it was 1x squared, right? All the ones that we did last class were 1x squared. Today, we're going to tackle them when they're not 1x squared, but some other number, x squared. They're a lot harder, unfortunately. Okay, so let's try number 2 here. It says for the product, 3x plus 2 times 2x minus 5. Let's calculate the product and sum. What did I mean by that? Oh yeah, product and sum. So let's do that. So here are the two numbers in this case. It's a plus 2 and a minus 5, right? Those are the two numbers. What's the product of those two numbers? So the product is negative 10. And the sum of those two numbers is negative 3. So then my guess is that if I actually multiply the thing out, I'm going to get just what we got last class. There's an x squared. Then the sum would be in the middle, right? Just like this minus 7x, but here it looks like it's going to be a minus 3x. And then the product would be at the end, so a minus 10 at the end. That's my guess. Move this up a little bit. Okay, so now Katrina's looking at it and say, well, wait a minute, you know, there's a 3x and a 2x. That's not going to give x squared. So, okay, let's update it 6x squared. But it turns out that that sum part in the middle it's not going to give us a minus 3 in the middle. So let's actually multiply this thing out. So either double distribute or FOIL or whatever you do, but let's write this thing out. This is supposed to illustrate that it just doesn't work, and so we'll need it. This is going to motivate that we need a new technique because it just doesn't work. But I don't want you to take my word for it. I want you to see it didn't work. So what do we get when we FOIL here? So first, what do we get? 6x squared, outers, minus 15x, inners, plus 4x, last, minus 10. Okay, so FOIL or lobster claw or something, and then we'll combine terms. 6x squared minus 11x minus 10. So my guess had a minus 10 at the end. Did we get that right? Yes, we did. Katrina made my guess better by putting a 6x squared. Did we get that right? Yes, we did. And the guess in the middle was that the sum, which was minus 3, was going to show up. Did it? No. Out of left field, we get a minus 11. Minus 11 is the right answer to this problem. But the thing we did last class was just, oh, the sum is always what pops up there in the middle. So the point of this example is that the product sum just isn't going to work. It just doesn't work. So let's go down to this next page. Number 3 says factor this. Normally factoring things with a 6 in the front of the x squared is hard, but we just did this one, so you can write the answer. How does that factor? Meaning we're looking for 2 sets of parentheses. It happens that we just multiplied things out and we got exactly the 6x squared minus 11x plus 10. So what goes in the parentheses? Everybody buy that? That's just saying the same thing we said on the previous page. But this was kind of miraculous because it happened that we had just done something which gave us the answer 6x squared minus 11x minus 10. So we want to process. Okay, so number 4 here. As we've just seen, factoring 6x squared minus 11x minus 10. Everybody know the word factoring? We're using it all the time now. Factoring means turn into a product. Factoring means turn into a product. Right here, I would say this is a sum or a difference, a couple of differences. Subtraction. What's the main operation in between? Is multiplication. So we turned addition or subtraction into multiplication. That's what factoring means, okay? And the same kind of thing, if I say find me some factors of 24, give me two numbers that multiply to 24, 6 and 4, 2 times 12. It's the same word, factor. Factor means turn into multiplication. Okay. So number 4, as we've just seen, factoring 6x squared minus 11x minus 10 involved first terms whose product was, what was the product of the first terms? Is 6. I'll put the x squared there. That's what the first terms gave us. And then in green here, last terms, what was the product of those? It was negative 10. Everybody see that? And so are you willing to buy that you can just grab that negative 10, whatever's there, like that's going to be the product, and whatever is here, that's going to be the product for the first terms? Like I see the, if you give me 6x squared minus 11x minus 10, I feel pretty comfortable saying, okay, I need a 6x squared. That's only going to come from these two guys multiplied together, right? That's where we're going to get the x squared term. So if I want a 6x squared, it's going to be 3x and 2x, or what's the other way to get a 6x squared when you multiply two things? 6x and 1x, right? So it could be either what we ended up with, which was 3x and 2x, or 6x and 1x. And then I can look at this minus 10 and say, okay, the minus 10 is definitely going to come from multiplying these two numbers together, right? In this case, the right answer was positive 2 and negative 5. But there are other numbers that multiply to negative 10. What else multiplies to negative 10? 1 and negative 10. There are other numbers that multiply to negative 10. What's that? Yeah, is 5 and negative 2. Is that the same as this? 5 and negative 2? It's different, right? This is a positive 2 and a negative 5. But Jenny said, give me a positive 5 and a negative 2, and that's going to be different. So when you see these kinds of, difficult problems, like with a 6 in the front, anything not 1 right there, you could just do trial and error. You know that you need to build a 6x squared, so you got to put two things there that give you 6x squared. You know you need a minus 10, so you got to put two numbers there that multiply to minus 10. Unfortunately, the trial and error can be a very exhausting process. Depends on how many things you have to try. There are 16 possibilities in this example. I've listed them all out here for you. I didn't want to write them all down while you were here. So notice we have 6x and x. Does that give you 6x squared? Yep. And then all the way down this column, well, actually, no. So all of these things here involve 6x times x. Yes? And even though it looks like there's a lot of similarity, you should try to convince yourself they're all different. All 8 of these things right up above here are all different. Positive 1 and negative 10. Negative 10 and positive 1, it sounds the same, but it's different because when I do the outers here, we're going to get a negative 60x. Yes? So the 6 goes with the 10 when I do the outers. Does the 6 ever go with the 10 in this problem? No, the 6 will go with the x and the 6 will go with the 1. The 6 will never go with the 10, right? It's different. Here the 6 associates with the 10. Here it never does. So in this case, moving the numbers around, even though it's the same numbers, minus 10 and positive 1, it changes things. So you could do 1 and minus 10 and 1, minus 1 and positive 10. That's changing the signs on the numbers. Minus 1 and positive 10 in the other order. Or we could do the same thing with 5s and 2s. 16 different possibilities. There is a correct answer here. The correct answer is the one that gives us this. In order to figure out which one of the 16 works, you have to FOIL all of these, or at least FOIL them until you find the one that magically gives you the minus 11, right? It's a process. I don't think it's the best process, but you could do this. And so if you choose to do it this way, you can ignore the method. I mean, I don't want you to ignore it. I want you to look at the method we're about to propose here as an alternative to this trial and error. But if you just choose trial and error, it's totally fine, but be prepared to maybe spend a long time churning through all the possibilities until you find the answer. Additionally, it's not just it takes a long time, it's work to make sure you get all the possibilities. It's real easy to miss something when you're trying to write them all down, right? Which one of these is the right answer? 3x plus 2 and 2x minus 5. It was just a miracle that we already knew the answer. It's this one here. I don't think I did that on purpose, that it was the last one, but like it could be the last one, right? You go through every possibility until you find the one that works. And how would you know that it works? You would FOIL or lobster claw or something. And if you do that, you'll get 6x squared minus 11x minus 10. And then finally, you stop. You found the answer, okay? So here's an alternative. 6 says your textbook goes through a factoring procedure that uses a rectangle. They call it the box method. You should read it over. I have nothing against the box method. I'm not going to illustrate the box method at all in this class, but read through it. And maybe on Wednesday, because we'll take a quest on Monday, maybe Wednesday, if you have questions on the box method, we can take them. We're going to learn a process that, that I've seen called funky factoring. It's basically equivalent to this box method that's in the book, but it's going to look different. It's just presented slightly differently. I don't think it's any easier or harder. I think it's the same amount of work. It's just a matter of how we write it up. So number 7 says, here's an example problem worked out next to the step-by-step procedure for funky factoring. So in the left-hand column is the process written out in English. In the right-hand column is an example. We're going to factor 6x squared minus 11x minus 10. Now we already know the answer to this because we've done it several times today. How does that factor? Times what? Yep. That's what we're after. 3x plus 2 times 2x minus 5, but we don't know the answer already. So if you fast forward, you'll see that answer right at the bottom of this process. So here's the idea. What you're first going to do, says part A, this is rewrite the trinomial. That's the thing with the 3 terms. It's underlined in purple right now. That you get by removing the a from the front of the trinomial. A is the first number you see. It's next to x squared. How much is a? 6. So you're going to remove that number. A is 6. And move it to the back. What's that? Thank you. We're going to move that 6 to the back of the trinomial by multiplying it by the c. Maybe I should put up here, ax squared plus bx plus c is our standard lettering. So you're going to pick the a up off of the x squared and you're going to shove it into the c by multiplying. So we're going to take that 6 and we're going to multiply it by the negative 10. What do we get? Negative 60. Everybody see it? Just pick the 6 up, lift it off, multiply it by the end. It's a very strange thing to do, but we'll do it. And when we do that, we end up with this guy right here. Notice it's not 6x squared anymore. The 6 literally gets picked up and moved into somewhere else, okay? Strange. Now what we're going to do, part B, factor the new easier trinomial using the PS idea. Why is this easy? Because it's a 1. And everything we did last class was when it was a 1. And if you pick up the 6, it will become a 1 every time. So we're going to factor this thing. So we're going to write down again our P and our S. What's the product supposed to be? Negative 60. And the sum? Negative 11. That's what we're after. So we're looking for factors of negative 60. Just list anything you can find. Don't worry about the minus 11. For me, I do things in a very orderly process. I'll say, okay, I'm going to divide that by 1. What do I get when I divide it by 1? Negative 60. Then I'm going to try dividing by 2. Does it go in? Yep. 30. I'll divide by 3. Negative 20. Divide by 4. Negative 15. Divide by 5. Yeah, it's negative 12. Yeah, we have trouble with 12s. Like, we're good up to 11, and then like something magical happens, and we can't do 12. 6 is in minus 10. 7, it doesn't go in. So I'll just write the word no. You just keep going. Most of the time, it doesn't go in, but you can do this every time, right? Just divide by 1, divide by 2, divide by 3. It's pretty quick. And then we'll find the sums of all these things. When I add up the first row, 1 and negative 60, negative 59. Go ahead and add every row. And in theory, you could stop as soon as you get to the magic sum, which we said was negative 11 in this case. And I found it right here at 4 and negative 15. Everybody see that one? That's the winner, 4 and negative 15. Oh, I didn't follow my advice. What did I not put on all these positive numbers? Plus signs. Okay, so I'm going to write it here. You don't need to write this, but what does that mean about factoring this guy? Well, they all started with x and x, right? And then you would put the numbers you found. What were the two numbers we found? Positive 4, negative 15, plus 4, minus 15. Yes? And if we had only been asked to factor this thing in red, we'd be done. That's how it factors. So what I just wrote in black is right down here. It's kind of hard to see now, but it's this guy. X plus 4, x minus 15. Yeah? But we're not done because we weren't asked to factor this one. We did this because we took a very first strange step and grabbed the 6 and plopped it into the end. So here's the next step in the process. It says part C. In the factored version, put the a back in front of the x in both sets of parentheses. How much was a? A was 6. I'm going to squeeze a 6 inside of both parentheses. In front of this x, I'm going to put a 6. And in front of that x, I'm going to put a 6. And you can look at the very next line, and that's exactly what's happened. I'll scroll up just a little bit. This guy right here, if you stick a 6 in front of each x, you see this line? That's what happened. We stuck a 6 in front of both. Okay, that's the next part in the process. The number that you peeled off in the beginning gets plopped back in front of both x's. And then here's a real strange thing to do. It says part D, divide each parentheses separately by the greatest common divisor of the terms in the parentheses. What number goes into 6 and 4? 2 is the biggest number, right? So I'm going to take this 6x plus 4, I'm going to divide it by 2. The greatest common divisor of 6 and 4. What's the biggest number that goes into 6 and negative 15? It is 3. I'm going to take both of those guys and divide by 3. And then I'll write out a tiny bit of detail here, but we have done this kind of problem before where we would take it and split it into 2 fractions. You guys remember doing that? We had the plus or minus business. And when you split it into 2 fractions, you can then cancel. The 6 and the 2 reduce to 3x, and then the 4 over the 2 plus 2. And 3x plus 2 is this guy. So all we're doing is taking the 2 and dividing it into both of those terms. In our heads, we're kind of thinking of splitting it up. When I take the 6 and divide by 3, what do I get? I get 2. When I take 15 and divide by 3, negative 5. And then I will say that this guy right down here is the answer to the original problem, which is exactly what we were expecting. Take a look at the top of the page. What do you see? This was the answer, right? But the nice thing is that we built this answer from nothing as opposed to going through 16 different trial and errors. We figured this out, right? We built it. It's not just trial and error and then cross your fingers and hope you find the answer. We built this. Okay, I'm not saying it's the easiest process, but it does get easier with practice. So let's try this one together. Number 8, 3x squared plus 16x plus 5. And just to be really clear, we are trying to factor, which means ultimately we're trying to fill in those 2 sets of parentheses, okay? So I'm just putting that out there as the goal. 2 empty sets of parentheses, we're trying to fill it in. Okay, how much is A? It's 3. And the very first step is to grab that 3, pick it off of the x squared. Where do we put it? At the end, by multiplying it by the c, which is the plus 5. So this becomes 16x there plus 15. How about the first term? is x squared. So that's taking this 3, picking it off, multiplying it there at the end. Okay? Make sure you pick it up. It doesn't still stay in the front. Questions on the first step? Okay, now we're going to factor this. Why is factoring this easier than factoring the original? A is 1, right? And if A is 1, 1x squared, then what little shortcut can we use? The product sum idea. So that's what we're after. What is the product in this case? 15, I'm going to put a positive, yeah. What's the sum? Positive 16. And then you fill in. It's not that many possibilities. Factors of positive 15. So I heard 15 and 1. Other factors of 15? 3 and 5. I mean, the fact is, if you see that you've already found the answer, you don't need to make an exhaustive list. You can just stop. Are there any other factors of positive 15? We could do 2 negatives. And clearly that's not going to be the answer in this problem, but I just want to make sure that we see that there are other ways to build positive 15 besides the first 2 rows. So just make sure you're aware. You can put 2 negatives there. And then we'll do the sums. What do I get in the first row? 16, which is the answer. So I could have stopped before we filled in the rest of the table. Okay, so that means we have now factored the easier blue trinomial. What goes in the first ones every time for us? X and X. And then what were the 2 magic numbers we found? We'll highlight this row right here. What were the 2 numbers? Plus 1 and plus 15. What's that, Katrina? We're gonna insert the 3 right now. So everybody okay with the x plus 1, x plus 15? And that step right there is kind of why I like this, because it refers to everything we did last class. So if you got good at the factoring from last class, then you get to use it again here, as opposed to maybe just starting brand new with a completely unrelated technique. Okay, this is going to be kind of funny. I'm going to copy those things exactly as they are, but I'm going to leave a little space in the front of each one. So x plus 1, x plus 15. And what goes in the space? Is the 3. That a that we grabbed off, we finally have to pay for it now. We're going to put a 3 in front of both. 3 here, 3 here. Okay, and the next thing to do is to divide each parenthesis separately by whatever the greatest common divisor is. Let's jump to the second parenthesis first. What goes into 3 and 15? It's 3. So we're going to divide both of those guys by 3. And now what goes into 3 and 1 is just 1. So sometimes you can't do anything. I'll just put divide by 1. It won't change the answer. And then I think we just have to write it down. When I divide by 1, it's unaffected. So that's still 3x plus 1. Divide both of those terms by 3. What do we get? X plus 5. That's the answer. Yeah, 1x plus 5 is fine. So 3x plus 1 times x plus 5. Questions on the process? Ben? For both of them? Yeah, then you would take it out of both of them and you'll end up with 2 copies of the same thing. That could happen. Other questions on this method? All right, so then what I'd like you guys to do in your groups for the next few minutes is the 3 examples here in number 9. So you're going to factor A, B, and C. There is a little suggestion that you might want to use your calculator in the last example. When it comes to factoring, what's the very first step for part C? Is to move the 18 and multiply it by the 6. So I think that's 108. So negative 108, which you might not happen to just know off the top of your head, all the factors of negative 108, your calculator can help you, right? 108 divided by 2, divide by 3, divide by 4, you can just churn through them. Okay, so see if you can do A, B, and C. There is an answer key, but work with your neighbors as well. So it seems like most folks are doing quite well on the factoring, which is great. I haven't filled in the tables here, but I've written the products and sums, so if you didn't quite finish, this will be here as a reference. Let's move on to number 10, which says sometimes we need to combine 2 factoring techniques in order to completely factor a trinomial. So completely factor means factor until you can factor no more. So let's look at a numerical example. What if we had the number, let's do 36. Can you factor 36? 6 times 6, yes? Can you factor those 6's any further? We can. So this is really 2 times 3 times 2 times 3. Can we factor the 2 any further? Can we factor 3 any further? No. Those are what kinds of numbers? Prime numbers, which means we can't factor them anymore, right? So I would say that this has been factored completely, whereas this one, you can still factor more. You can make it more multiplication. So when we say factor completely, we mean you got to factor until you can't factor anymore. So let's try part A here. This 10x to the 4th minus 50x cubed plus 60x squared. First of all, it is very frightening because what's the highest power on the x? 4th. Whereas every problem we did last class and every problem so far today, what's the power on the x? It's 2. X squared is every example we've done so far. So that's a big giveaway. There's something funny happening. So I've underlined what I think is the very first thing to try for any kind of factoring problem, and that's to factor out the greatest common factor of all the terms first. So looking at the 10 and the 50 and the 60, what number goes into all of them? 10 goes into all of them. And then looking, I have x to the 4th. So imagine 4x is laid out in the first term. And then you have x cubed. So 3 separate x's multiplied. And then you have x squared. How many x's can you take out of all of them? You can take 2 out of all of them. You don't get to take out the biggest number. You can take out the smallest number. So that's what we'll do. So we said we were going to take out a 10, and we're also going to take out an x squared, and then we're going to put big parentheses to fill in. Okay, let's jump to the middle term, for example. I'm just going to put a middle term here. The idea is that we're supposed to multiply 10x squared by something that goes in the blank, and it's going to give us negative 50x cubed. 10 times what will give me negative 50 is negative 5. And then x squared times what will give me x cubed is a single x. That's what goes right there. Negative 5x. And really what's happening here is we're taking the 50x cubed and dividing it by the 10x squared. And so I'll put that over here on the side because you guys did lots of problems like this. Negative 50x cubed, that was the middle term. I just started in the middle. Divided by 10x squared, that's what we put in the front. And you cancel. Negative 50 over 10, negative 5. X cubed over x squared, x. Negative 5x, that's what goes in the middle. So factoring really means dividing. Dividing out something. Okay, let's see if we can fill in the first part. So there's supposed to be something here and then something else over here. So let's do the first one. Yeah, let me write it here in blue. We'll write the division. What was the first term? 10x to the 4th. And then we're dividing everything by the thing you pull out in the front. So in this case, it's always 10x squared. When we cancel the 10s, how many x's are left when I cancel? There's 2. So we get x squared. And then, so let's see, that was equal to x squared here. And then the last one, put it over here. So what was the last term? 60x squared divided by, in this problem, 10x squared. And we cancel and we get 6. I'm going to put a sign in the front. Positive 6. Plus 6 goes right there. So that is called factoring out the greatest common factor or the greatest common divisor. Any questions on that? And with practice, you certainly don't need to write out as much of the detail as we did. You don't need to write the divisions. You understand how to factor it out. You can just write it. Evan?
Could we make it even more simple?
How?
I don't know.
Just do it.
Let's do it. We do want to make it more simple. Yeah. Just look at the big parentheses, the x squared minus 5x plus 6. We spent all of last class factoring things that look just like that. So let's do that one separately. I'll put it down here, x squared minus 5x plus 6. This is a product sum example, right? So just to save a little bit of time, I'm just going to write the answer, but this is a very familiar product sum thing. I'll start with x and x. Product is supposed to be positive 6. There's not that many possibilities. 1 and 6, 2 and 3, or all negatives of what we just said. We're trying to get a negative 5 in the middle, 1 and 6, or 2 and 3. 2 and 3, right? With negatives. Negative 2, negative 3. So that means that our final answer is we pulled out the 10x squared, and then we decided x minus 2 and x minus 3 was the other part. So there probably hasn't been a whole lot of motivation in this class is why we're spending time factoring. Right now, you're just going to have to trust me when I say factoring is important, and it's a fundamental technique for solving tons of equations. Right now, we're just kind of playing this algebra game. It will have a point. It might not be clear at this moment what that is. Any questions on that? Okay, let's try part B. Again, the first technique, factor out the greatest common factor. The biggest thing that goes into all of the terms. So what number goes into all the numbers? 2. How many y's can you take out of all of them? Just a single y. So we factor 2y out in the front. And then we fill in big parentheses. So see if you can fill in those parentheses with your neighbors. The factoring out the GCF. Yeah. So the idea is it's supposed to be 2y cubed. You're going to factor out a 2 and a y. So you're going to divide this guy right here by 2 and y. What happens when you divide by 2? So you have 2y cubed. That's what we started with. And you're going to take out this 2y that we're putting here in the front. So first, so do you understand why it's the 2y that goes in the front? Okay, right. So what you're looking for is you look at these 3 terms up here at the top, 2y cubed minus 10y squared. What number goes into all those numbers? You want to look at the numbers in the front and see what goes into all of them. So what number goes into 2, 10, and 12? What is it? 2 goes in. So that's the 2 that we see in the front. And then you have some y's to play with, and the shortcut is that you're allowed to take out the lowest power of all the y's. So what's the lowest power on all the y's? Which term are you looking at, the first, middle, or last? The last one. So there's a single y up there, y to the first. So that single y is why it's here. So that's where this guy comes from. Yeah. Anybody have what goes in the parentheses? Agree? Disagree?
Agreed.
Several people agree. That's good. That's the right answer. So, right, and then we're going to factor this guy as well. But before we factor this one, before we finish factoring this one, let me say that factoring out the greatest common factor is a really important technique. I think I mentioned to you guys at the start of the semester that I have taught this class only once here at GCC, and it was several years ago, and it was a summer, so it was really quite different than this. And when I put together the notes here, I didn't put really anything in for factoring out the greatest common factor. Not really. I kind of took for granted, oh, all we do is greatest common factor, not even thinking that that would be something to kind of practice at this moment. And a couple of days ago, one of my colleagues says, hey, Ian, we need to put in more stuff here. So if you are a little bit confused about the greatest common factor, it's on me. I mean, I should have put more stuff in here than I did. But when I wrote this, 3 months ago, I wasn't in that place where it's like, oh, we need practice with the GCF. So I don't know what I'm going to do. I might come up with like a supplement or something, just more practice of just that part. So if you're lost at that detail, just move past it. That's not the most important thing for today, right? So I'm owning this, and hopefully we'll have some more materials for you to practice with this soon enough. But if we can move beyond that, let's finish this one. This is another thing in the big parentheses with a product and a sum. So we need the product to be -6, sum to be -5. -6, how are we going to get it? -1 and +6. -6, +1. Same thing with what other numbers? 2s and 3s. Okay, one of them is going to be the one that gives you -5. It feels like 2s and 3s, but it's actually not in this case, so you got to be careful. What is this? Y -6 and Y +1? So that one there is factored completely. Okay, if we're ready, we move on to the next page. Okay, so a few special factors. So we're just going to FOIL these guys together. We've been foiling for a while. X plus 3x minus 3. Can you guys FOIL those together? FOIL or lobster claw? Good. When you FOIL, do you see something special happens here? Yeah, the outers and inners, the middle part, they happen to perfectly cancel, right? Minus 3x plus 3x, no x is left over. So that's very strange. It doesn't usually happen, but it does in this case, and so we just get x squared minus 9. Go ahead and FOIL the one with the 7s. What happens here? Same thing. Plus 7y minus 7y cancel, right? And we'll try one more for good measure. 2x plus 5y, 2x minus 5y. So exactly the same, but different signs. And so this one just looks a little more complicated because there's two letters in there, but it's the same idea. Do we get those outers and inners canceling? So I got 4x squared minus 25y squared. Any questions on that? Okay, so then how are we going to know if it's one of these funny ones where the outers and inners cancel? Well, do you see the pattern here in the original problems? Every one of these things over here, what could you say about what's in both parentheses? Same, except one is plus and one is minus, right? They're exact copies, except one of them is a plus, one of them is a minus. And if that's the case, then you're always going to have the outers and inners canceling because they were the same, except one was a plus and one was a minus. So here is a formula. For us, we're kind of reading this formula right to left at the moment. If you do a plus b times a minus b, it's the same, except one is a plus and one is a minus. So the outers and inners will cancel, and you get a squared minus b squared. Do we see it for the first example, x plus 3x minus 3? This says you do a squared minus b squared. You're just doing the first, and you're doing the last, and everything else cancels. X squared minus 9. So the important direction for us for this formula is the other direction, the factor direction. So somebody has already FOILed together two things, and they got x squared minus 4. Sorry, x squared minus 64. And we're supposed to recognize, oh, wait a minute, that looks an awful lot like some number squared minus some number squared. What's the first thing that's going to give us x squared? X and x. What same number multiplied together will give us 64? 8 and 8. And what about the signs? 1 plus, 1 minus. Either order is fine. See if you can try the other two rows of this using that same formula. Okay, so let's see if we can fill this in together. What number will give you 100? Something times itself? 10. Got to be the same. What will give you a squared, b squared, but they have to be the same? AB and AB. It is not okay to say, oh, I can get a squared, b squared. I'll just put a squared in one and b squared in the other. Because if you do this with 1 plus and 1 minus, right, it's not going to work. When you multiply these guys, sorry, not those guys, these guys, what will you get? 10b squared. What will you get here? 10a squared. They're not going to cancel, right? You need them to cancel. You need them to be the same. So you can't just willy-nilly put whatever you want. You got to put two copies of the same thing for this special formula. So I think a bunch of people told me correctly, AB and AB. And what about the signs? Plus and minus makes no difference what order. The next one, x to the fourth minus 16. What two copies of the same thing will give you x to the fourth? Is x squared. What two copies will give you 16? 4 and 4. And the signs? Plus and minus. Eight is no good. It's got to be two copies of the same number. Yeah, so you can't do 8 and 2. They have to be the same. We can go further. One of these two parentheses looks exactly like the formula that we've been using. The formula says if you have something squared minus something squared, which one of these is that same form? Is the x squared minus 4. It looks just like something squared minus something squared. So I'm going to copy the first one. X squared plus 4 I'm just going to copy. But the other one is about to expand into two new sets of parentheses. We are trying to get x squared minus 4. First terms have to be the same. Last terms have to be the same. So what first terms will give you x squared? Is x and x. What will give you a 4? 2 and 2. What about the signs? Plus and minus. That one is done. So this new formula that we're seeing here, this a squared minus b squared, is a really important formula. You're going to see it a bunch. So the giveaway is that you see some number that is squared and some other number that is squared, and a minus sign in between. If you see a plus sign in between, see the x squared plus 4, you can do nothing with it. If you see a plus sign in between, can't do anything. But if you see a minus sign, it is this brand new formula. It's a good question. It feels like we should be able to do x plus 2 and x plus 2. So I'm going to write that here. Isn't this equal to x plus 2 and x plus 2? What do you get for the first? X squared. What do we get for the last? Plus 4. Isn't that exactly what I wanted? Did we do the whole FOIL? So let's do the outers and inners, but they should cancel, right? They don't cancel. When we do the outers and inners here, they don't cancel. They add up. And the only way they're going to cancel is if one of them is a plus and the other is minus. So unfortunately, even though Sam's suggestion is a good one, it seems reasonable, it doesn't work. So there's a real fundamental difference between two squares added and two squares subtracted. Two squares subtracted. You can handle the subtracted ones. So if we understand that, then this next example on the top of the page should be easy. X squared plus 9. Can we factor this? This one at the top, x squared plus 9. No. So you can say prime, just like a prime number, or cannot be factored. Yeah. If you see a plus, can't do anything with it. Minus, you're obligated to do something with it. Plus, can't do anything. Okay, and then we're going to look at this last one. Is 12 a square? 12 is not a perfect square, right? 3? No. Yeah, so it feels like we can't, I mean, it's not something squared minus something squared because 12 is not a perfect square, like 100 we had. We could do 25, we could do 16. But we can factor something out of both of these numbers. Forget the squared formula. What can you take out of both? Factor out of 3. And then what do you have left when you factor that 3 out? Minus 4. And you can go further with that one. So the giveaway here is that 4 is a perfect square. X squared is also a perfect square. So that's the new formula. What do we get here? Good. For my benefit, can you guys give me a sense? How much, if any, of this factoring out did you do in 105? Did you do any of that in 105? Okay. Okay. All right, any questions on this brand new formula? Okay, so there are 3 concepts for today that we talked about. The first one was funky factoring. So I need you guys to get to the point where you can do funky factoring, but moreover, you need to know why this is an example of funky factoring. What do you see in that one that says funky factoring and not the simple product sum? Is it 6x squared? What other number could I put there to make it still funky factoring? Yeah, if it's any number in here other than 1, it's funky factoring, right? If it's 2x squared, it's funky. 3x squared, 4x squared, 5x squared, all funky factoring. What's the only one that isn't funky? Is just 1x squared. Okay, so that's the funky factoring idea. Then there's this factoring out the greatest common factor. And I think that I did not do a good job in preparing you to do that part of these problems. Factoring out the greatest common factor is probably the most important factoring technique of all. So I don't mean to say it's not important. I mean to say I didn't put enough stuff in here. So I'm going to try to supplement and give you guys something next week to get more practice with that. And then the third thing, also an important factoring formula, is this difference of 2 squares formula right here. It's a good question. I have no idea. Yeah. Yes, Davis. This is not on the quest. Yeah. It'll be on the next quest. Yeah. Good. Okay. So I think, yeah, we'll start our weekend like 55 seconds early. You're welcome. How about that? And we'll see you Monday. Show up early if you can.